In instantiation of member function, grow dot item pointer template each item U is not const. U is not const. What is U? U. Threadsafe unlocked. Reference, not const. I have so no idea why I did not run into this before. This is exactly what I was afraid of yesterday, and then it didn't happen, and I was like, apparently I can use unlock cast to cast away a const. Now it turns out that I can't, which is good, but why only now? But the problem is that shared item pointer is a const UnlockedBase, which should not give write access. Therefore, we cannot cast it to a non-const reference, which would give write access. But yeah, clearly we need to write access here. I mean, this comes from I guess just using a non-const item. And yeah. Confused. No, it is unlocked. Okay. I just thought it was UnlockedBase. So yeah, though then this cannot be an cannot be in ConstUnlockedBase, I think. Which is what I thought anyway. Ugh. Let's try to change that into the UnlockedBase. It seems to be stopping on the same line or what? Cannot cast protected base class item to threadsafe unlocked. There's something else. But here we're talking again about unlocked cast. Oh, that happens now in instantiation of function template specialization. Unlock cast to an unlocked reference. Node in instantiation of member function. Item requested here. That's the same thing. Class protected, it's same error somewhere else. So apparently we have what is happening here? This one. Yeah, the cost makes sense, the error doesn't. Cannot cost protected base class. Okay, this is the unlock cost for when U is unlocked, an unlocked reference, that is the case, and not an unlocked const reference. It's exactly the case. And derived from U is derived from data type is derived from base. Yep, okay, also correct. Hello RR. Yeah, okay, this is all correct. We have an unlocked base, probably const. Well, no, not const. We have an unlocked base. We pass it as a reference here. And U is an unlocked reference. Cost is nonsense. This line is nonsense. What the hell is this? Okay, so original is an unlocked base, which, what? Which wraps an M base. Which is, well, a base pointer, but I want to find it. Here. So non-const pointer to base. And I want to cast this to an unlocked. And unlocked is derived from T. Oh, that's the reason. So T is derived from base. Unlocked is derived from T. So it should be possible, if it wasn't for this protected, to cast the base class of T directly to the unlocked. That's what I'm trying to do. But it's not allowed because this thing is protected. Can't we then do that when we are our friend of this class? The friend of unlocked? Either that or I need to I need to do something dirty. Could cast it to T and then reinterpret cast it to an unlocked. And it would be kind of sad. I don't want to do that. No, I don't want to do that. this is a friend. So, well, it's a friend of who? It's a friend of whatever we are inside now, which is UnlockedBase, not unlocked. So I'm being a friend of UnlockedBase, so I can access mbase. But I also need to be a friend of Unlocked itself. Otherwise you can't do this static cast here. That's a bit complex. Might not entirely be impossible. At the very least we need a forward declaration then, before the unlock clause. Stupid music. Different music. Okay, that's better. So forward declaration must have the same requires, so I hope that works, because it's already using data type here, for example. But yeah, I don't know. I guess we'll see if it compiles. And then I have to add this as a friend to unlocked, and then hopefully that works. But this is using UnlockedBase, so then we need a forward declaration for UnlockedBase. Yeah, this makes all of ConstUnlockedBase a friend, but that would not include a friend of that class. Nevertheless, maybe I should have this friend call a member function of ConstUnlockedBase and have that do the cast, because that's a friend anyway already. And now we do not have a forward declaration of UnlockedBase, so I have to add that as well on. Here's the forward declaration. Yeah, we should move all the forward declarations up, at the very least these two. So I need them before this, and then I guess I'll just put them here. and then pray. Use of undeclared identifier base. Oopsie, we don't have base here. I would say I can add a type name here, but I think then we have a specialization, partial specialization of a friend, which I don't know, feels like it's not allowed or something. This is not going to work, right? Yeah, let's try that, but it's definitely going to give me some other error. Use of class template UnlockedBase requires template arguments. Argument deduction not allowed in function prototype. Ridiculous. No. Use of undeclared identifier base. But okay. Type name base, type name policy mutex 2. Suppose I need to use a 2 here as well. And then this is again base, comma, policy mutex 2. Add attribute is protected member. What are you saying that we got past that point? Apparently. Oh, this is pretty shocking. Well, apparently. Okay, so let's take the right access. And then we are getting an arrow to add the attribute. I'll do make j of -1. Yeah, not. Cannot cast protected base class dot item to unlocked. That's the same error, so we did not get past it. But then again, this is not the same function. Type name base, comma, type name policy mutex 2. Now it is the same function. I think we already have a base here. Yeah. So So now I want to use the base policy mutex here for UnlockedBase. Or maybe I don't care and I just every base is okay, except that I'll even change this in base too. Now I managed to crash the compiler. I have no time to report it. Takes an hour. And then they don't fix it. As usual. Yeah, it's just too hard, I think, to make this thing. I'm mentality shift. Sorry. You're back. I think it's too difficult to make this a friend of unlocked. How can I back out of my changes? I think I recently committed. So this is threadsafe. I can go to threadsafe and then probably over on dot threadsafe. See, I added those. I moved to forward declarations. I added that forward declaration, and then I tried to add it as a friend to unlocked. This is where it was moved from, and here we added stuff. So I can just undo everything. It's completely related to the change that I just made. Good. Mentality shift, yeah. You just started out and it's pretty high level, I'm afraid. I'm wondering how it helps you. It should be all magic what I'm doing, no? I mean, I think it's definitely, if you spend a lot of time watching my videos and yeah, you learn something like the right way to format stuff. I don't know. The fact that you have to put const on the right side of the type. I'm a minority in that fact, by the way, but still, it's the best thing. But this, that should not be helping you, right? Is it not like way over your head? Concepts, templates with concepts. What I'm thinking is I can try to hijack the whole class being a friend, maybe. So this set of class is not allowed. I think I can, yeah, I can have a private thing. I can just make a static private static function that returns U. That's what I need in the end. U is a reference. It still has to be a template then. Why is this friend not static? Yeah, okay, so if a friend is a free function, right? So this is not a member function of the current class. But I need it to be a friend in order to access mbase. And I need it to be not a friend, so that it is just a real member function, static or not. So I can then add the unlocked base as a friend to unlocked. So I'm going to call here this function, which I shall give the name unlocked cost. Why not? And then we want to have pass base pointer. And then this must return that. And here return that. Which then will use a copy elation, because the return type of a function is a temporary. And if you pass that to immediately to the return type of another function, then it's just not going to copy it. It's just going to be the same object in the same place in memory. Don't even have to inline it, don't even have to use optimization. So now, because this is a friend, we can access mbase, and then because this is not a friend, I should be able to cast the protected base class to U. If this is a friend of U. And I guess I could try to add a... it has no restrictions because it's just only called by this one, and that has all the restrictions. So it's a rather easy function. I guess I can just add it as a friend, except that it's a member now of a class that isn't defined yet. At the moment I have to define it as a friend. So I cannot add the function itself as a friend. I'm suddenly thinking something else. I'm not super happy with the static here, although I don't think that makes a difference. Anyway, we just add the whole class as a friend, then this is also a friend. And I have already added the ConstUnlockedBase as a friend. So maybe you should just move this to the base class and then be done with it. ConstUnlockedBase was already friend. So what about just add this here, private and all. No, I have no idea. Let's just see where it gets stuck now. Hello? Okay. Explicit qualification required to use a member unlocked cast for a dependent base class. Do I have to translate that, or do I have no views at all? Let me check. 4 views, okay. So we are calling now unlock cast on the base class of the current class. The current class is UnlockedBase. And UnlockedBase is derived from ConstUnlockedBase, and ConstUnlockedBase has the function defined that we are trying to call. And it says that, yeah, this function. And it says you can't do that for a dependent class. Dependent means in this case dependent on the template parameters. Well, it's totally dependent on template parameters. So we have to very explicitly say that it is part of the base class. It refuses to figure that out on its own. Now this should definitely work, although I'm not sure I need to provide template parameters. Let me try it without, I'm not sure. I think it should be able to figure out that when I do this const unlock base, that I mean the current base class. Sometimes you don't have to pass, yeah, in this case we do. Unknown type. What a beat unlock type. Yeah, okay, well, now it's very clearly the base class, right? Oh. No matching function for call to unlocked cast. Note in instantiation of function template specialization. Threadsafe unlock cast requested here. Candidate template ignored. Couldn't infer template argument U. Oh. I'll have to pause that as well. U. Yeah, and then it says, well, you told me to call a template, a static template function of my base class, all spelled out, and still I don't understand you. It's telling me that I have to type that it is a template. As if it wasn't able to figure it out itself. Oh boy. unlock cast is private member of da 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 da. Oh, I made it private. Yeah, no, now it should be protected, of course, because I've made it part of the base class. So it wasn't that logical to move it to the base class. Okay, I've got where is it? This is const. I already have other stuff here. What the hell? These are public. I don't want to make them public. Now you can finally pass it, I think. It looks like a new error. No matching member function for call to add. Add only accepts an item pointer, or both an item pointer and an access type. And what I'm passing here is just an access type. Why would I do that? I think I'll just pass the pointer then. Member reference, dot graph pointer, and so on. Yeah, we saw that one a billion times before. Now remove is non-const, so I need to create a what from that thing, but then we have to call item on it, otherwise we don't have the unlock type. And unlock type is just dot graph pointer unlocked type. Okay, what I wrote in the description of the video. Mentality shift. I really hate that auto close thing. It doesn't help at all in my opinion. At all. If I encounter an editor that does it, like OneBox, then I'm spending an hour to search how to turn it off. This is a battle without end, right? Because the errors will keep coming and coming. Well, I'm not used to it, maybe that's it. Yeah, because this is extremely annoying. I mean, I type from my spine, not from my brain. My neurons are... I think of a word and now my spine types a word. Including a lot of commands. So if I type, say you type a class foo. No, I don't want to have that there. I want to have it here. Now I type ding, return, ling, bidding, because that's what I want. And then I have to type escape and then shift O or something to continue typing. Okay, so I typed it myself. Now you are saying it's helpful if the editor does that. Okay, so we are here. I'm typing this, and then we are automatically there, like here. And then I can hit return, and then we are faster. You say where we want to be. No, the semicolon is missing. So I still have to press escape, go down, shift A, semicolon, escape, and go up. This is hardly a difference, except that I'm used to very rapidly type 3 characters and then go up. And now I have to think, what? I didn't type it. Where does that brace come from? It's just annoying. And I'm sure that it's a minor thing. If you're used to it, then you're used to it and you don't want to live without it, and the other way around. But I've been typing programs for over 40 years, so I'm not going to change that. Reprogram my neurons in my arms and in my spine, and maybe also in my brain. I'm also not using a lot of shortcuts, speed ups, whatever in Vim itself. I'm just tired of, I don't know, I'm old. I'm not going to learn things that need the reprogramming of my brain. I'm eager to learn new things, but not the way I type, for example. That's a thoughtless process. And you can program yourself from scratch if you don't have anything programmed when you're young, but when it's already programmed in and you're old, that's impossible to change it. That would cost me way too much effort. I did switch from typing with 6 fingers and looking at my keyboard to typing with more or less 10 fingers and not looking at my keyboard. And I did that at a reasonably old age. Maybe, how old was I? Let's say 40. And that was already excruciating. To force myself not to look at the keyboard and then type in a different way that I had been used to for 28 years. Yeah, I'm 58. Yes, a thumb, index finger and middle finger. The big problem, I was very fast with that system, fast enough. But the problem was that I was looking at the keyboard. And that's tiresome. It's way more relaxing when you can just look at the screen while you type. But it requires a different way of typing, I'm afraid. And then still I did fallback. So I'm not really touch typing as they would teach you. And every now and then I still look at the keyboard. So I'm now somewhere halfway touch typing in my old system, I think. Because it was so baked into me that I just, even after forcing myself to learn to type reasonably fast with 10 fingers and without looking at the keyboard, I still went back every now and then. I mean, like I said, I let my spine type. So I'm not worried about if I just look at the screen and then my hands type the word, then I don't really care how they did it. and it's not a normal touch type thing. Yeah. Now what is going wrong in my program? Encouraging. This is already a CXX file of a test. Maybe I'll reach the end today. But yeah, this is definitely not happy. Does not make me happy to make this super long. Let me think. This index container set test. I think that Hello World must compile by now, right? I mean, that already worked, I guess. Apart from core dumping. It's a deadlock assert. But at least it compiles. I'll go look at deadlocks later. Make the label node test, I think. Maybe it compiles. Doesn't even. Oh, just typo. A bool typo. What? Ah, even more bool typo. Need to create a temporary right axis type. Yeah. So node pointer is a dot node pointer, and now we do here dot node pointer unlocked type cred dot item. In insertion, oh wait here, no matching member for function call to remove graph item. This is a const reference to an access type. Remove graph item. It seems to be taking that. Well, yeah. Like I said, I have a lot of history mentality. I started coding when I was 12, so that's 46 years ago. You know, when computers just came out, basically. So I started coding on TRS 80. So I can't tell you what is the best way to learn programming and coding and use of editor and all whatnot with 100% certainty to someone who's young at the moment. But my personal opinion is indeed that a graphical user interface is not really helping in the sense that you will be way faster if you don't use a mouse. And that's the reason of Vim. You do touch typing and your fingers are on the right keys to also move the cursor around. Type all the commands. Vim is just way faster. If you continuously have to go to the mouse back and forth, which I also do, by the way, to continuously copy stuff and then paste it again. But well, it's I don't know. My experience is that when I do something for years and years, and then I switch to the right thing with capital R and T, then after doing that, I'll even formulate it cautiously. After I switch, then 2 weeks later, I don't want to go back. That has always been the case for any major improvement in my technique, or what is it? So let's say you use a Microsoft editor with all kinds of whistles and bells. You switch to Vim. It's not easy at first, but already after 2 weeks you have the feeling that it is an improvement and you want to continue with it. Then you know that they made a good decision. So if let's say it keeps being a pain and you keep feeling that, oh, I want to go back, then yeah, I don't know. Maybe it wasn't a good change. But I did have that experience with switching from my look at the keyboard 6 fingers method to touch typing. That was really painful. It took me many months of forcing myself. So I guess it can happen. Maybe it would take some people a really long time and a big fight with themselves to switch from one system that I already know, like a certain editor, to Vim, because that's a big change and might be even comparable if you already used for years to non-Vim. Then yeah, it might take longer than 2 weeks before you start to appreciate it. I forgot what I was doing. Yeah, let's read exact error. The error is that there is no matching member function for call to remove graph item. Passing what? Candidate function not viable, no known conversion from. That's not an access type. So the function takes a CRED, a const read access type. which you see here. That's the access type. And we're trying to pass this, which is, I don't know, the item template. It's not an access type. If I call item on this, I get the unlocked type, so I still have to lock it. And I would say that's pretty strange, because this screams that item R is an access type, right? But apparently it isn't. So I should not look here, I should look further back, or maybe add an requires here, making sure that it is an access type. That's the problem is just here. So we have to lock then before calling this. I'm kind of scared of just locking the mutex everywhere where I call something, because then the amount of deadlocks that I will run into afterwards is going to be humongous. But I also don't want to push the locking up and up and up until I get to the user code. Not too much anyway. If I pass access types down from function to function, then in the end I'll end up with that the user has to provide the access types and do the locking, which is reasonable, but also will make it a very ugly interface, and I'm not sure yet. Right now I'm just trying to get it to compile, and then we'll fix the deadlocks, and then we'll think again about maybe changing the API to make it look better from the viewpoint of the user. So I guess I'll just take a log here. So the outer subgraph is what we pass. That's a reindeer graph. I think my reindeer graph already has an unlock type. Well, it does. The item pointer template does. Seriously, detail. So the outer subgraph is a reindeer graph which has an item, because it is an item pointer. Here's the item. That returns then an unlocked type. And the unlocked type I can just pass to whatever access type is defined for that same unlocked type, and the unlocked type is this. So this is the type returned by this function. And then just you put the access type behind it, cred, red or what. And then you have something that is an access type, and the lock has been taken. Remove was taking a cred. Well, it wasn't, but now it is. And then the cred can be moved to the remove graph item, which indeed takes a cred. And here I see the exact same thing. outer subgraph. So we converted, take the log, convert it to an access type, a constant read access type, which then pass to add. And I'll find this remove back. That was this one, right? So it is the same thing here, where add graph item must take the access type is first argument, which is also a thread. But this add also accepts an item pointer, but you also have to pass. This one doesn't. We have more items, or more adds, I mean. Add of dot graph something. I think that must be this one. Yeah, this one. I could use this one then, which then does the thread for me. Might as well use that. So just pass the item pointer. That's why we got the compile error here, not there. This must just be the item pointer. Or rather, can be. So maybe I should allow that for the remove as well. And then just do the locking inside that new function. Why not? Well, why not? Let's do that. So there was outer graph. I mean, if I do it for add, then I should do it for remove. Now let's keep it a little bit symmetric. Huh? No, it does. That is this one. It is pass an item pointer and that does the logging for me. This then calls that, and that calls the thing above, and so on. So then why did it not compile? Oh, because it calls this function instead of that function. And the reason of that is that there's, I think, a base class of what I try to pass. And it prefers an exact match using a template argument over degrading the pointer or the reference to a base class. So we do need a requires here to make sure that only access types make it through here, and the item pointers will call this. Now that's annoying because how the hell do I make sure that it is an access type? Hey Louis. And Reg is next. Hello man, didn't see you. What is my access type? access const. It's stuff that belongs to primitive at the moment. So it's either access const or const access or just access. Threadsafe slash again threadsafe. Could just check that it has the type unlock type, I guess. What else is special about access types? Nothing else, I think. Yeah, that it has these things, I guess. I don't know, I'm gonna abuse that. It's not very clear that that would be sufficient. What am I doing here? Grov. I think I need 2 requires. So this would only match if the access type has that type unlocked. And that should work for now. Can do that here as well. No matching member function for call to remove graph item. Louis, yeah, the errors that I'm currently solving are giving most people problems, I think. You know, the long stuff with a lot of template things in it. It's also, yeah, neurons, I'm afraid. I solved such an incredible amount of compiler errors of this type that you can't do it much faster, I would say. Or maybe I'm not talented and other people can, certain people can, but if you see these errors for the first time, and of course you're going to be 100 times slower, and it's just hurting your brain. And you're going to have to do it thousands of times before that starts to become less. So I'm kind of surprised now. Here we have a failure to find the function call, and you would say, well, maybe that's because now the requires doesn't work anymore. In instantiation of, who cares where it comes from? And then it says candidate function not viable. Oh, no known conversion. That's something else than the requires is failing. Wasn't this what you already saw? Yeah, that's exact same as before. A non-access type cannot be converted to an access type. So we didn't make any progress whatsoever, it seems. Now what the hell? What the hell? Oh, I added the wrong requires. Yeah. Oops. Okay. Oh, where's my requires? Oh, there. This requires makes it an... no, I didn't. Wait a minute. If access type has an unlocked type, then it is an access type. Or a graph item. Or a graph item. That's why it doesn't work. Damn it. That was not a good requires. Everything has an unlocked type here. In the user code. Like literally everything. So that doesn't work. No. Let's do it more precisely. I'm just going to demand that it is one of these things. Can be converted to, or is... oh boy, how do we do that? Is specialization of? I'm afraid needs... all three then. I'll just do these three then for now. Access const access and access const. Those are the three possible. Currently the three possible access objects. Use this as well. With a tiny bit of luck, I can do just base class. Access const. Access const is the base class of const access, which is the base class of access. So maybe a specialization works, but I'm not sure. I don't think so. Let me see. So very confusing this, because I think the T and the U are like replacing each other. This T is that U. Okay, so we pass the specialization off here, and then we demand that that is, I think, equal or convertible, no? No, equal. This T is that T. Holy, but I think it's not going to work. What I could do, I could change this to make it is derived from. I'm not sure that's the same thing as is specialization. Could make a new one that is derived from a specialization of. Or I can just not be lazy and add all of them. And then I need pass the right namespace. These things are defined in namespace threadsafe. Okay. Lisa, sorry if this is totally off topic, but do you have a policy of not numbering lines? My lines are numbered. What do you mean? You can see it here. This is line 127. If I move the cursor, then you can see the line number here. You can also jump to it. You can type 127, capital G, thing, jump to line 127. I think now you got past that problem. It's a totally new problem. Well, the only way to make 100 sure is by running this, because that was caught catching it. No, totally different. We are past this problem. Attribute list is a protected member of graph_vis.itemID. You said you were doing that last week, Luxit. What happened? Printing a graph. If I take a look while printing the graph, that is like asking for a deadlock. Definitely going to deadlock this. But let's just do it and then we'll see where we deadlock. Not sure why this thing was calling item first. Usually I have to add item. Remember, reference type dot table node pointer is not a pointer. Well, that's because I removed the operator arrow. Yeah, this is again the user code, which is Let's go back to trying to compile that one thing. Make a label node test, and it compiles. Great. So now hello world compiles. And this compiles. Which one shall we do next? I think this one. Oh, okay, looks it. I was just teasing you. Why is it so hot here? 26 degrees. I feel like buying an ice cream again. I'm also, well, never mind. How late is it anyway? 17:27. 15:27. Tomorrow I will go to Amsterdam or to the birthday party of a girlfriend. Why is it called girlfriend? She's like 70 now. It's a woman friend. A friend, I guess. And yeah. That are like difficult things to do, right? I have to get up earlier than normal, and then you must take a shower. It's not like you can decide not to. And then I have to find a bus stop. I know where my bus stop is, but they are working on the road, so maybe the bus stop is not there anymore. And then it's gonna be 2 hours in total of traveling. And then back again 2 hours. What am I gonna do in the time? So I must, before I go to bed, I really have to charge everything. I mean, imagine that I woke up and it turns out my phone is almost empty and I have nothing to do while I'm sitting in the train for 2 hours. It's just stress, stress, stress. And I don't even know if it's going to be fun when I'm there. I'm so autistic, it's unbelievable. But I'm going, so yeah. I won't be streaming tomorrow. Okay, so the problem here is that table node pointer used to have an operator arrow, which we're using here, which just returns a table node item. But now we must take a lock before we access anything, and well, a write lock. So usually I would have to do something like call item on it now first, so we get the item, and the item was changed to an unlocked type. So now we have to get that type, unlocked type, and then get the write access type of that, and then take the lock, and then we can access it. But this is a very unfriendly user unfriendly line, I think. Plus, the same function is using table A again here. And again here. And all of that in the same function. And normally I would say, well, just log it once and then, so create a table A W. So now we have an access type here, and then I can just use that and then replace all the table A's with table A underscore W, and that looks reasonably nice again. You just have to explicitly lock it and then you can access it. But if I do that, then it's just basically going to be locked for the duration of the whole program, which is definitely not working if I keep it locked while calling write dot, and most likely also is going to deadlock somewhere else, because then nobody else can ever lock it, right? So what this thing is doing, this, well, add attribute not, but somewhere it's going to say, well, I'm going to lock that thing again. Well, not like this, probably this one then. What is add container taking? Add container is taking a table node pointer and then tries to write lock it. So that's a deadlock. Now can change normally I would say, well, then you have to pass the write access type, because I already have it, might as well just pass it like that. Yes, so we change this and we just pass that as argument. However, oops, container is also used directly. So then suddenly I have to pass both or something, because I still need the container itself. What is that add doing anyway? This add is a graph, add on a graph, and we are passing a table node pointer. I think this one. The table node pointer is a pointer, so, and the table node is an item, so the base class has an item pointer. So we are going to call this function, which then takes a lock again. Bang, deadlock second time. So then we have to change this one as well in accepting a thread as argument, but also an item pointer still, because that is being passed to add. So, okay, I could call that one directly, of course, because you already have that here. But we still need both then. And then what is doing? Add graph item. Add graph item passes the item there, unlocked. So this is now the item is returns the unlocked type of the item, which hopefully is not locked. Yeah, that's not going to be locked, because we know that it is already locked in this case. So that then is put into the unlock type is put into the items vector, I think. Map. Okay, map then. What is a const item pointer? Oh, right. Where's my const cost? There is a const cast here. Do I need it? Confusing. I need an AI that is just really smart. It just can look over my shoulder, understands everything, and points out, oh, I see that you did it right for 90%, but the other 10% is wrong. Let me fix it for you. I think it's what I have to do. I'll just have to pass 2 arguments to all those add stuff. I was talking nonsense 5 minutes ago. This is not the same item. It's not a deadlock here. So we're talking about container. But add does lock it. So if I pass an access type to this container, then I have to just pass container comma that access type. So we need to pass both. And add then locks it how? thread. Anything actually. No, this is thread. So I can use a thread type for add itself, but I wanted to call this one. That would take any access type. It's more like the access type that I need for graph item, which is in a C. That's a thread, yeah. Okay, let's just try this. Unlocked type thread container R. Then we pass here. Oh, we need 2 of those. Damn it. I do it in the same order as I need it for airtime. Add is using item pointer comma access type. Container R. Ooh, I was going to do an undo. I copy this. Let's do an undo. Node pointer. Access type second. Yeah. So now I changed add container. No, probably have to change this one as well, where you just move a container. Let's see what happens. We call add on a graph with an R value reference. Never heard of that one. What the hell? Attribute list add. There is no such add. What? No, no idea. Let's comment it out. Let's see who's needing that, if any. So then theoretically I could keep the right log here and then pass that. To add container. Need to do the same thing for B. Underscore W, underscore W, underscore W, underscore W. So lock that thing. No, we're going to get the same error or problems here, I think, the graph and the edge. So yeah, here I have logged the table node pointer and then I unlock it again here. And I need a log again here. So I could keep it logged while I do all the other things. And I'm not a fan of keeping a mutex locked for a long time. It's probably a good idea to lock it again here, I guess. We don't need a what, just a cret. Yes, it's the same thing, except that here I did not unlock it, but let's keep it symmetrical. So unlock the right lock. Table new W is no longer available below that point, and then I'm locking it again. Except I use a thread here, and then lock that. Yeah, so now we got there. That's not too bad. So I have the same problem for the die graph, and later on we'll get the same graph for the edge pointer. So we could lock the G0 here. And I'm not sure. I think that we're pretty safe-ish, hopefully. Not even sure though. I have the feeling that we are pretty safe if, as long as G0 is not being passed as a function argument, that we won't get a deadlock. Except here, the right dot is going to try to read the graph itself. You can see that if you follow the right dot, yeah, it's trying to lock the graph of its own tracker, so it's doing a self-lock. So apparently it's not entirely safe. Maybe it's not going to be safe either to keep G0 locked. Or is it? Or any of these functions. So I guess we'll see. For now, I guess I'll shoot unlocked type, right axis type, D0W from D0.item. I just let deadlock. Let me run into it and then I'll unlock it. Okay. No, I think this should work-ish, except for the edge. I'm just going to do the same thing here. Unlocked type what? E1 right locked from E1.item, which returns the unlocked thing. Because this is a pointer, so you have to call item on it to get a non-pointer. Very confusing. AKA the API is not correct, because this just is not looking intuitive at all. Okay, do we just succeed in compiling this one as well? Yep, so now I'm just checking it again. Everything compiles. No, didn't even try that one. Everything compiles except this one. reference dot node pointer. The lib is not a pointer. Get what? I think it's just best to keep the log. So I have to log something to get a reference to the attribute list. And now we turn that into a pointer. This is no longer required. Turn that into a pointer, but if then you unlock the mutex, then someone else can access that thing and also the attribute list again, while we are not done with it. So we have to keep that lock. In fact, it's probably just silly to store a pointer anyway. I guess I should just assign what directly from this. Get value returns a string view, so you have to explicitly say that you want to make the string from that. By the way, so this is the attribute list that we want to lock. No need to make that a pointer anymore. Right, and then I still have to log it. So I guess this is a node pointer. And that is a graph pointer. everything bloody compiles. Whoa. Okay. Time for ice cream. Yeah, maybe I should go now because it's not dark outside yet. Well, that's nonsense. The sun's not really shining. Plus, I'm sitting here with the curtains closed anyway. Oh wait, that's the whole point, of course. If I go outside, then I'll actually see some sun. Maybe better to do that now and then continue earlier in the evening. But you guys want to see a test? Well, I predict deadlocks all over the place. And then we have to fix the deadlocks. Or crashes like this. But yeah, that's just a deadlock. AI mutex try to recursively lock it. That's not allowed, therefore we crash. All the other things will do the same thing, I guess. Holy moly, this one finishes. Amazing. Nope, totally out of history. Top project. I want to see this, so we write that to top project slash dot, and then we run dot type png input top project dot output top project hello output top project png, and then we do jpeg view. Exciting. N0 and N1. Yeah, not really test in the sense that I just cannot remember anymore what this should be. It's showing N0 and N1. Is that a good thing? Label node test. We have a graph. I create a rectangle node. That's, well, there was a rectangle around it. This should be automatically added to G0 and have the what N0. And we create a second graph. Oh, we're moving the first graph, which already has a node added, to G1. And then I'm, what the hell, doing here? Passing N0 to N1, and I guess then that is being added to the graph that belongs to N0, which is moved to G1. So now N1 is also added to G1. And we set on both a label and we print it. No deadlocks. Amazing. Actually, why am I not logging anything here? How is it even possible? How is it possible? I'm not logging anything. Okay, if I call write dot on G1, which is a graph, then it locks it. It locks it for me. Call initialize on items. Calls initialize on, well, all the items, but I have no trackers. No trackers part of a graph. Are you telling me I can access this node trackers thing without logging anything? So disappointing. That's probably the case though. I think I only added a lock now for item template. So this item template thing here does not have any memory of its own. It's just a tracker item. Nope. Totally missed. Total miss. Yeah, I don't think these things are being protected. I think I protected namespace dot, but this is not namespace dot. So we don't have any protection for any container in this namespace yet. And that is what those containers is what is being used here. But then, for example, set label. That should say lock attribute list, right? So set label is, well, that's locking something here. I have another label there. So rectangle node set label. What is this? Graph is class. No, it's something else. Index container set label. Label node, maybe this one. It just sets it. No locking. No locking whatsoever. Yep, might as well jump to rectangle node. That is derived from label nodes. Label node has a thingy here, and there's no protection whatsoever. So at the moment I call set label, we have a problem. Yeah, I would do that concurrently. But on the other hand, you know, why would I have two threads trying to set the label on the same object? Might as well argue also that two threads going to call write dot at the same time? Don't think so. This just does not make much sense. And here we have graph, moving a graph. Yeah, that is also like single threaded by insinuation. What is the word? Implied single threaded, because I'm moving it. If a thread is moving G0, it's just, even if it, that would be locking stuff, so it's not UB, undefined behavior, then still it's undefined behavior, because as soon as one thread is done with moving, then what's the other thread going to do? Throw an exception. Oh, I tried to move it, but it was already moved. No, just external synchronization should take care of the fact that you're never going to move G0 twice in two different threads. So here's no locking required either. It's good enough, as it were. But this is a different story. Have a G0, many threads could get access to that, and then one thread calls it, and the other thread might call, well, the same thing or do something else with G0. So this really needs to lock G0 and everything in it while it's doing its thing. And it's not, because this is not dot graph, it's just graph. Rectangle node is doing the following thing. It's using label node, the constructor. We're calling this one the weak pointer to the root graph with a what string, which is then passed to the node. The root graph itself. Graph with a node. So that would be this one. And that is calling, it's not doing anything with the root graph, just passing that to ItemTemplate. ItemTemplate. Which ItemTemplate constructor takes a root graph? This one. Here it's called root graph tracker. That's what it is, right? Let me go back. Yeah, to be called the root graph tracker here, I guess. Anyway, this is the standard weak pointer of a graph tracker, comma a node pointer. And the enable if happens depending on T is a node tracker or not. I think this is the one, right? So also because of the comment. So we're constructing an item from a root graph tracker, comma the object. It's an item pointer. ItemTemplate. ItemTemplate is a node tracker in this case. It is a base class. So we are calling this one. Okay, item with item constructor that start with a root graph tracker and 3 elements, 3 arguments. That would be this one. So it's a default value. Okay. The root graph tracker is simply stored. Not doing anything with it. But we're doing something with it here. Okay, this is possibly the parent graph tracker. And then the only thing we're doing here is nothing like, well, you call use count on it. That would be a race condition, of course, if others are using it as well. Yeah, it's pretty complicated race condition. Even protecting the standard weak pointer with a mutex won't protect us from fuzzy use count, I think. So we might get here anyway. Extract root graph. So it simply assigns root graph tracker. It's not really adding anything to the graph. I'm kind of confused here. You would think that it is. Oh, this is adding it maybe. Inform owner of. Nah. Could be, could be. Okay, this call set parent graph trackers. Object is found in a register memory region. I cannot find it back. There's a log here anyway. Memory region to owner linker. Here's a lock. Place element. And here we're changing something of the current object. Of course, I would say. Should current object should be locked, and in some way, calling it on memory region usage. That's just a tracked object. No, yeah, well, forget it. I don't have time for this. It's thread safe or it's not thread safe. If it's not thread safe, then what we will see in the end is that sometimes it does this and sometimes it does something else, or maybe it crashes. So not reproducible. But I'll just run it 5 times, and if then 4 of the 5 times it does something that is the same, then that's the right output. It's just for debugging this, so I don't care really. And if it's doing something else all the time, then I can find it. Then we can find out what where it is going wrong. What the hell will it crash? Yep, that did crash. We're trying the lock here node pointer while it is already locked. It's a table element. So table element is already locked here. I guess. At least the item of it, whatever table element is. We're running over all table elements of a container. Write HTML2. Yeah, well, yeah, you cannot have anything locked at all, I think, while writing stuff. It was kind of expected. It's still not really clear to me, but the answer is going to be that, well, let's not lock D0. Oh, wait a minute. I have to log it if I want to call it like that. Well, let's unlock everything else. Let's put it that way. Everything else being... this one maybe. It's still locked. A lot of stuff that is already unlocked. Looks like just a test. Main that is not unlocked then, but that's what we need downstairs, right at the bottom here, to call it in the first place, G0W. Let's try to keep that locked then. And then here's one but it's in the scope that is unlocked here, and then we go down again, a scope, and another 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 scope, and no, not another scope. V1 last W. And that's a scope. And that's a scope. And that's a scope. And that's in the scope. The only thing that could possibly still be locked is this thing here. That was it. That was it. Whew. That's pretty amazing, I think. Yeah, that kind of still looks the same as it was before. Then let's do this one. That looks up. This is also, well, not also, this is, yeah, trying to lock item pointer. Well, it is already locked apparently. That's here. So inner subgraph is already locked at this point. Yeah, well, totally. It's locked there. So I can solve that by passing the locked thing, the access type, second argument, I think. Now we're trying to look graph. This is where. Well, that could be the root graph. And the root graph is always locked. Keep that locked. It's Yeah. Could it be the root graph or not? I think I can just see what it is. Graph item, or what is graph? Graph is an incomplete type. Yeah, really? I don't think so. So useless. I think this item pointer is the graph. So yeah, that is already locked. It's being locked right here. Is this item pointer a graph? Any graph? Yep, it is. It's outer subgraph. So what could be that we're trying to add outer subgraph to, I guess, the root graph here. Which then we get here, and then I'm locking, I'm read locking it. That being outer subgraph, so we are locking the outer subgraph, read locking the outer subgraph, which then calls this, well, this add, which then calls add graph item with the still locked outer subgraph. Which then tries to set the digraph on outer subgraph to make it equal to the graph that we are adding it to. Which recursively tries to change the digraph for all the subgraphs, including the inner subgraph. So this might be the inner subgraph, which is also locked. Oh, yeah, where's this one called from? Not getting it. This is a different problem. Duh. Shit. Add to graph. I give up for today. Oh, at least. I want to do something else. Let's go for a walk or something. What is this? Well, I found that Vermont put his name onto my invention. Those guys that have everything, that are the inventor of everything, they just were born earlier. And then it's named after them. It's not fair. Let's play a game of chess. Mm-hmm. No time left. Bloody hell. Okay, that's a rule. Oh, I might actually win this. Surprising, surprising. Oh boy. I try to win this, but then I go there. And he loses on time now, of course. Yeah. Sorry, guy. Oh, it was a good game. But only because I won. Because somewhere halfway I found it a horrible game. I'm really wondering where I went wrong here. This is still a draw. Well, wow. I'm shocked. How is this still a draw? Oh, he's giving his bishop. Yeah, he's giving his bishop. Yeah. That's how it is a draw. That's true. Okay, then did I miss the win somewhere? Draw. Pretty much a draw everywhere. Oh, here I did something wrong. So what did I do? I took the knight. I should not have done that. Oh, damn yeah. I can just attack it again, but then what if it goes there? Don't see it. You can both go both ways, because the jack is also attacking my rook. This is apparently better. And then just go back. And he goes there again. And then it sees that king f3 didn't do anything, because that's going to be a draw then. Yeah, I would never have assumed that I had to go back here. Really. So how am I going to win this then? I mean, I think he would have taken there. Oh, and then he loses knight. Right. So he has to do something like this. Why not defend the rook? Oh, the bishop is also attacked. Oh, that's the trick. Yeah. That's the only move, because here I take the bishop. If it goes away like that, I take it. If it goes there, I take the bishop after exchanging the rook. If it goes anywhere else, I take the rook. Seems like the only way, and then attack the bishop again, and then that's the only place. And then we can take this pawn. Of course, now he cannot take this pawn. Okay, so why? Oh, he cannot go there because of the. Oh, wait. What? Could take the pawn immediately. Almost as good. No, seriously, I don't see this. I don't see it. I mean, I see I attack this twice and it's defended twice. And I attack the bishop. That was the whole point. So the bishop is stay on this diagonal. So yeah, I do something, and then black remains having a problem. But I cannot go somewhere where he can give check. So this is the only square. I could have seen that. Go here, go there, and then just take the pawn. Again, let's go back further. I'm already up here. At least I did a good move there. Bishop is a bad move. Yeah, black is better. -4. Black is way better. Maybe we should go back forward through the game. Let me go forward. Draw. It's not the best move apparently. Should take. Plus 0.7. Minus 0.8. Wow. I should take. Oh, that's interesting. Here it says it's oh, going back was better. Yeah, doing stupid stuff apparently. Called my pawn back though. Now I am better if I would just push the pawn. Or the other pawn. But I didn't. I'm still better. Knight comes out. Again, hit the bishop. Hit the other bishop. Also good. Now I am even better. Hit that bishop. I did. Engine move. King to the side. Also what I did. Brilliant. Now I'm winning. I just have to put my bishop away somewhere, and I didn't. I put it here. Yeah, that was not the best move. Probably go here and then there after moving the rook. It's maybe more threatening. Okay, still plus 1.4. Oh, what a bad move. +6. Going the rook from there to there. Why is this +6? I just made my battery and I'm not pushing this pawn. Not even considering it. Push the pawn, then what happens? I can just take this pawn, that's all. Oh, I'm winning the queen. I saw that later, that I could win the queen with b4. Almost win it. So you cannot take it like that. Yeah, I'm threatening b4 now, so this loses a piece. What can he do? So if you do this, also b4, yeah. Well, this, also b4. And if it just takes it then. Still +9 because I don't see the +9 really. I'm +3 in material. Apparently this is winning. I don't need a queen. It doesn't even want to exchange the queen. I'm still winning anyway. So strange. That's nobody on senses. Plus 10 in the meantime. No idea how white is winning this hard. It's gobbling up pawns. That's about it. What's wrong with the defending the pawn? Okay, I go with that one. At least it defends the pawn. Oh, there's a second rook. No, we make a hole. No, we don't. Yes, we make a hole. Just take it. Take the knight. Knight goes away. King comes in. Knight goes there. Okay, plus 24. I don't see it. Probably because of this or something like that. Because those don't do anything. My rook can come in and then give mate. That's ELO 4000, I think. This too. I'll just give away the bishop. Why? I would never, ever, ever have seen this move. You think, well, go here, attack the bishop, but then he pushes the pawn. And I lose my bishop. Okay, get one pawn back, but that's not winning. But it is. So which move would I have done? Probably retreat my bishop. Retreat my bishop here or something like that. Okay, it's still winning, but cost me 2 points. So 3 more moves and I'm losing again. Why did I not see this? Okay, we continued with that move. Oh, even that. I saw it here. No, you're kidding me. I saw that I almost called a queen here. And then I was like, okay, can it go there? Not there, not there, not there, not there. Oh, it can still go there. Let's play this pawn to take away that square. So already saw before and still I didn't push e5 with the tempo on the bishop. That was a way, 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 way better solution than this one, which doesn't force anything. So he just moves the, you move the knight. Plus you could take there, also no queen catch anymore, make a hole here. Yeah, it's really bad. Still plus 5.5. What? I can still do the same trick. No, the queen can go away. How is this a trick? Okay, attack the bishop and that pawn at the same time. And still I don't see it. Unbelievable. He decides to give a piece here. Why is that? What? Just go away. We give check. You go there. Now we retreat. Pins the bishop. Win another pawn. Gives another. I really, really want to give all the pieces away. Yeah, this is really sad that I did not see this move, because I put these things like this to tag there, and I'm not considering this move. Well, maybe I'm not considering it because defended 4 times. So basically you think, well, and then oh no, it's with a pawn. It's defended with a pawn. So yeah, I should have done that, of course. Okay, I'm a moron. I'm going for a walk, which I said.